Um, so this is a homework question I've got a bunch of times. It is a question where you're asked to relate the height of a child to the head circumference of the child. And we're trying to see if there's a linear correlation between the two variables. Most people are okay on A, B, parts A and B. I haven't gotten any questions about that, but I did have a questions about part C and D. So I just wanted to show you real quick in StatCrunch how you are able to get the correlation coefficient. So you just load up the data in StatCrunch. Okay. And hold on, I think I have to switch over here to StatCrunch. Okay, so now you can see my StatCrunch window. And all I want to do here is to go to Stats, Summary, Stats, Correlation, select the two variables, and then just hit Compute to get the correlation coefficient, which is, I think it asks us in my StatLab to approximate to 3 places. So we just do 0.783, plug it into my StatLab, and go. Okay, now let me switch back over to my StatLab window. There we go. So in my StatLab, that gives us the correlation coefficient. But just because you have a correlation coefficient doesn't mean that you have a linear correlation, right? That just tells us how weak or strong it is. And so if the correlation coefficient is really near 0, the correlation is pretty weak. And if it's near 1 or -1, it's pretty strong. So what we want to do here is figure out if this correlation is strong enough to warrant us calling it a linear correlation, whether we can really say it correlates to a line or not. And the way you do that is to go to click this button right here, and it gives you the critical values table. And really what you have to look up here is the number of data points you have. And for our data set, we have 8 children, so there's 8 rows. So this means that whatever R we have, right, its absolute value has to be bigger than 0.707. And because our R is at 0.783, our correlation is strong enough to warrant us calling this an actual linear correlation. Okay? So we would say, yes, there appears to be a positive linear correlation. It's positive because R is positive, which just means as the height increases, so does the head. As the height increases, so does the head circumference. And because it's greater than a critical value, we can claim that this is a linear correlation. So I hope that helps.